Darius, this is Derek, we are part of the Android team.
Cyber team, I am Zach Aman.
The hardware team. So we are the RFI team. I'm Leon. I'm Wei Hao. We'll take the photos now.
In order to make sure our image recognition model was background agnostic, we ensured that the images used in the dataset contained a variety of different backgrounds. This was done by identifying the white part of the background side of the bounding box and replacing them with randomly generated patterns to create varied backgrounds.
For data collection, we took about 180 photos total assembled in 3 different locations with different lightings. We made sure to vary the viewing angle with each photo taken, and also accounted for edge cases by placing the image perpendicular to the Pi camera. For labeling of images, we use RoboFlow, an online platform for easy annotation of the images. After data collection, we annotated a total of 6,000 raw images before using pre-processing and augmentation techniques for training of our model. We used the YOLO V8 model and achieved an accuracy of 0.86 across test datasets.
So to dispute this connection, I think maybe we need a script that we'll look through all the PID and then close that socket so the socket doesn't stay open. What do you think? Sounds good. Yeah.
I think another thing is like we need SDM to send back acknowledgement though.
Oh, right.
Okay. I just got a script, right? So when SDM send back acknowledgement, then we process the next line to send to SDM again.
Okay. So at least we'll execute the instruction first. This one. Okay. Sounds great. Okay, so you say this is the path is generated by DFS. Okay. So what do you think about that?
Yeah, it seems good. But then I think for backup, right, so that we actually have always get a path, we should also implement a backup DFS as well.
Then maybe we can compare both. Then we see which one is shorter. Then we can choose that one.
But then if both give the same path, then how should we compare? For the goal probably.
Yeah, that's what I mean. Like how many images, the more number of goals. Just in case both do not find a path, then maybe we can just return the deepest path that they found.
Then we'll always have a path. So now we'll always go to some different.
To ensure our robot makes precise turns, we needed to make use of our gyroscope. We calibrated it by taking readings while the car is stationary and removed any offset and drifts. Once calibrated, the gyroscope's reading in angular velocity allows us to continuously track how much the car has turned, giving us a precise reading over its movements. We also utilized the gyro's reading to control the servo motor for the front wheels, adjusting the servo to compensate for any unwanted drifts. For the motor, we calibrated both motors to individually adjust to maintain equal speed when moving in a straight line, and dynamically adjusting motor power during turns based on speed differential between the inner and the outer wheels. Lastly, for sensor accuracy, we applied a low-pass filter to the readings for both ultrasonic and IR sensors. To test the filter, we first gathered raw sensor data under varying environmental conditions. Applying the low-pass filter significantly reduces the noise and improves the reliability of the distance measurement.
To reveal a product that will set the path for technology for the next decade.
This is Group 42's Android app. The button functionalities and layout placements are done by myself, Derek. The Bluetooth, map, obstacle, car functionalities are done by my dear groupmate Darius. For the features, we have opted for a scrollable map layout as opposed to others, so we're able to have a better and clearer view of the obstacle IDs being reflected. There are 2 ways to place the obstacles which aim to cater to the preferences of users. Firstly, the user can key in the XY coordinates and the direction of the list of obstacles as a string. The second method is aesthetically pleasing for visual users, which will involve directly dragging the obstacles onto the map. The obstacles are also sorted for easy viewing here. If there's a mistake, the user can simply drag it out the play area or replace the obstacle by dragging over it with another. Changing the obstacle is facilitated by toggle button disable dragging movements, which can interfere with the directional change process. The process is done with double taps, which make it faster than keying it in. We also provide the option to see the robot move in real time, by providing a variable size of the robot, coordinates, and starting direction. If users would like to move the car directly, they can use our retro 8-directional D-pad on the right. Instead of the traditional 4-directional one, which may fail to capture unique movement capabilities for the robot, ours will provide for more sleeker and accurate movement possibilities. As the robot moves closer to an image, you can take a picture for recognition. Once the image is recognized by a flash server, its symbol ID will be clearly updated onto its corresponding obstacle box here. The remaining buttons are used for 2 tasks, and if users will need to reset the arena, users can always press the button to go back to a clean slate.
Relax. Trust the robot. Trust the robot, bro. You got all 6, right? Okay, one more, last one.